is applied maximum and minimum problems. Applied maximum and minimum problems are practical math problems where we use calculus to find the highest or lowest values of a function in real-world situations. These problems are common in fields like economics, engineering, and physics. Why do we use it? In many applied problems, we want to find the largest or smallest value that a function achieves. For example, we might want to see the minimum cost at which some task can be performed. And so identifying maximum and minimum points will be useful for applied problems as well.
Hello, my name is Hazim Fatih bin Johari, and today I will present to you about how we can solve this first question from one Roman. So first we need to write the volume constant of cylinder, which is pi r square h. Then we put the volume that have been given from the question, which is 16 equal to pi r square h, and then we need to have this h alone, so 16 will be divided with pi r square. After that, we write the second equation, which is the surface area of the cylinder. A equal to 2 pi r square plus 2 pi r h. Then we put this h that we have done before into the h of this surface area equation, which is 16 over pi r square. And then what can we do? We can cancel out pi r and pi r square. Then the last equation that has been simplified is a equal to 2 pi r square plus 32 per r. For the first question for 2 Roman, first we need to put the equation for surface area that we have done before on first Roman, which is 2 pi r square plus 32 over r. And then we need to make this r upward, so we'll get 2 pi r square plus 32r power of negative 1. And then we can derive it. 2 times 2 will get 4 pi r. And negative 1 times 32, we will get negative 32r negative power of negative 2, because negative 1 minus 1. And then we will get 4 pi r minus 32 over r square. Then we need to let dr over 0 equal to 0. So 4 pi r minus 32 r square equal to 0. 4 pi r, we need to take this negative 32 over r square to the right side. So we will get positive 32 over r square. And then this r square, we can times it with the 4 pi r. So 4 pi r times r square, we will get 4 pi r cube equal to 32. And then we can put this 4 pi over to the right side, and we will get r cube over 32 over per 4 pi. And how can we remove this cube? So we can put cube root to the r cube and another cube root to the 32 over 4 pi. So when we calculate all this, the r will be 5.01 centimeter. Last, we need to do the second derivative to find the minimum value of the r. So 4 pi r minus 32r power of negative 2. Where did I get this? From this. So we can derive it. Negative 2 times 4 pi r. If we derive it, we get 4 pi. And negative 2 times negative 32, we will get positive 64 r negative 3. And then r power of negative 3, we can put it back down, which is 4 pi equal to 64 pi per r cube. And then we can put this r value, r equal to 5.01 m, back to the r cube. And then we will get 13.07, which is greater than 0. and if it's greater than 0, then the R equal to 5.01 is minimum value. That's all.
For question 2 Roman 1, we get that volume square plus linear is equals to 27 cm cube. From that, we can conclude that pi r square h plus 4x cube is equal to 27. After that, we're going to substitute with r and h into x and y. So our new equation is pi x square y plus 4x cube equals to 27. After we get the new equation, we need to put the plus 4x to the other side. So our equation is pi x square y equals to 27 minus 4x cube. After this, we need to single out y. So we need to bring pi x square to the other side also. So our last equation is y equals to 27 minus 4x cube over pi x square.
3.
For Roman 2, we get the equation 2 pi r h plus 16x squared. So we need to again substitute r and h into x and y. So we get 2 pi xy plus 16 x squared. After that, we need to put this y into the earlier equation that we get from the Roman 1. So we get this new equation that is 2 pi x into 27 minus 4x cubed over pi x2 plus 16 squared x squared. So now we can cancel out pi x in from the bracket because it's the same. So now we get 2 in bracket 27 minus 4x cubed over x plus 16x squared. So now what we do is we can expand 2 into this bracket. So now our equation is 54 minus 8x cubed over x plus 16x squared. So now what we can do is we can separate this equation into separate form. So now we get 54 over x minus x cubed over x. So what we can do is we can cancel out the x because again it's the same. So now our final equation is 54 over x plus 8x squared. So now that we can find the first derivative of this equation. So our first derivative is 54x minus 1 plus 8x squared. So now our first derivative is minus, we need to bring this minus 1 in the front, and so we get minus 54 and the power needs to be actually minus 1, so negative 54x minus square plus 16x. So now what we can do is bring this x to the downside because the power of the x is negative. So our equation is negative 54 over x2 plus 16x. So now what we need to do after find the first derivative, we need to let the derivative equal to 0. So we let 0. So now our equation is minus 54 over x squared plus 16x equals to 0. Now what we can do is we need to bring this 16x over to the other side. So now we get negative 54 over x squared equals to negative 16 over x. So now what we do, we bring all the x to the one side and all the number to the other side. So we get this negative 54 over negative 16 equals to after x squared we expand into x, we get x3. So after that we need to remove this cube. So what we can do is we need to cube square both sides. So we get this cube square negative 54 minus negative 16 equals to cube root x cube. So now we can get our x, which is 1.5. So after we get our x, we need to insert this x into the early equation that we get from the Roman 1. So we have y equals to 27 minus 4x cubed over pi x squared. After that, we can just insert this equation. So we get over pi x cubed. So we can just insert the equation y equals to 27 minus 4 in bracket 1.5 cubed over pi in bracket 1.5 cube, 1.5 cube, yes. So now we get the y value. So after that we can conclude that x value equals to 1.50 cm and y equals to 1.91 cm. For the last question, Roman 3, we get the equation that equals a equals to 54 over x plus 8x squared. So after we find the value of x, we can just substitute x into this equation. So we get 54 over 1.5 plus 8 in bracket 1.5 squared. So the final answer we get that 54 cm squared. So the minimum total surface area is 54 cm squared.
Assalamualaikum, and my name is Adam, and I will present for question 3. For question 3, the first Roman, we need to know the volume for cylinder, which is V equals to pi r squared h, and the volume given is 100 pi. So we can substitute with both equations, so it will turn into 100 pi equals to pi r squared h, and we need to make h as the subject. So when we derive it, we can get h equals to 100 over r squared. Next, by question given, the top and bottom for equals to 4 cents per centimeter square, and also for the side is 3 cents centimeter square. So for the area of the cylinder is equals to 2 pi r squared plus 2 pi r h. So we substitute for the 2 pi r squared times 4 because it is for the top and bottom, and for 2 pi r h we substitute the h value into this, so we can get for the top 8 pi r squared plus 200 pi r. Next, to 200 pi r we times with 3 because that is for the side. So it is proven that for the area and the cost is equals to 8 pi r squared plus 600 pi over r. As for the second Roman, we need to find the cost minimum. So first, the cost that we get from the first Roman is c equals to 8 pi r squared equals to a plus 600 pi over r. Next, we need to use the first derivative to find the minimum value. We will get 16 pi r minus 600 pi r power of negative 2. Next, we need to let dc over dr equals to 0. So we can substitute with the top formula. So we can get 16 pi r minus 600 pi over r squared equals to 0. When we need to make r the subject, so the final answer we can get r equals to 3.35 cm. Next, we need to use the second derivative test to find whether the minimum value that we get for r is a minimum value or maximum value. So the second derivative is 16 pi plus 1200 pi r power of negative 3. When we substitute r equals to 3.35, we can get the value is 150.554. It is greater than 0, so r equals to 3.35 is a minimum value. Next, we just need to find h, which is substitute r into the first formula with h equals to 100 over r squared. So we can get 8.91 cm. And the final, which is the minimum cost, we just need to substitute the r equals to 3.35 into the formula. So 8 pi times 3.35 power of 2 plus 600 pi over 3.35 equals to the cost minimum we can get is Rm 844.73 ringgit.
In conclusion, we can say that using maximum and minimum can save the cost of producing a product and also find the perfect volume for a certain product. That is all from us. Thank you.